Okay, I'm going to go over this starting with the multiple choice questions. First question says, where is the graph increasing on which intervals? So I'm going to go ahead and write on this a little bit. So increasing would be from there to there, also from there to there. That would be increasing. For decreasing would be there, and then here would be constant. So this is just a basic question of like, that I showed that little man, in the board. It's just as the man climbing up the mountain or sliding down the hill. So that's just all this one is asking. And because it has closed dots, we're definitely going to have brackets on these. So let's go back now and look at the answers, because it should be this section and this section. Okay, so yeah, from -6 to -4, so that's from there to there, yep. And then from 2 to 5, yes, perfect. Okay, so that one should be simple question. Let's go to the next. This one says the average rate of change on the interval -1 to 3 is negative. Which of the following could be the graph? So let me put this one in the picture real quick. Okay, so remember average rate of change is just slope. So from -1 to 3, a negative slope would be going like that. So we're trying to see, and now this is looking like decreasing, but we're saying like, where is the slope negative? So that's a different question than the previous. So let's just look at the first one since it's in the picture. So from -1 to 3, I'm gonna go ahead and look at this area right here. From -1 to 3, so like you can see, the slope at -1 is constant, the slope at 1 is positive, the slope at 3 is constant. So never in there is it ever negative. So it's always either positive, constant, so it's definitely not negative. So we can definitely say it's not that one. Let's go ahead and look at the other ones. -1 to 3. Okay, let me see if I can put both of these in the picture. Yeah, okay. From this one, for this one here, B, -1 is, it is negative at -1, but at 0, it's constant, and at 3, it's constant, and it's also like positive at 2. So it's negative, but it's not negative the whole time. So it can't be that one. The one right below it is positive at -1, constant at 1, negative at 1, constant at 3. So it's negative part of the time, but not the whole time. So that can't be the answer either. So let's look at D. Oops. And you can already see D is noted as the right answer, but let's just double check. Yeah, so at -1, yeah, it's starting to go down, 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 down. Yeah, so pretty much that whole time the rate of change is negative. And at -1 and 3, it is constant, but there's no other way to kind of say the starting and the ending, But you can see that from -1 to 3, it is writing down the whole time. So that would be a negative rate of change. Okay, let's go to the next. Okay, this one is a linear function is used to model the price of used cars as a function of their AHT. It is known that P of 4 equals 7,300 and P of 7 equals 5,500. Based on this model, which of the following is true? So what we would do for this one is we would find the rate of change. So what we're going to do is, so this is like, okay, so it's like, I'm trying to mark this up. Let's see. Okay, so it's kind of like they gave you 2 points, basically. They give you an X and a y, and another x and another y. So they gave you 2 points. So from the 2 points, we can find the rate of change. So remember, you're going to use that formula, which is y2 minus y1. So it'd be 5,500 minus 7,300 over x2 minus x1, so 7 minus 4. So let's go ahead and see what that would be. So 5,500 minus 7,300 is negative 1,800, and then 7 minus 4 is 3, and if you do negative 1,800 divided by 3, you will get negative 600, which would show this one, the price decreases by 600. All right, let's go to the next. Okay, so number 4 is even and odd functions. So this is what I gave you the assignment the other day. So basically for, for even, if you plug in a negative x for x, you will get the same answer. And for odd, if you plug in a negative x for x, you will get the opposite answer, the opposite sign. So these are the 2 rules. These are in the notes. It's definitely something you learned last year, even odd functions. So it's just kind of basically showing you like which one is the rule. It says which of the following supports the claim that it is an odd function and not an even. So again, you can see D directly shows the rule. If let's say x was 3, if I plug in a negative 3, I will get the negative version of that x value. C would be supporting that it's an even function. And then the other 2 just don't really support anything. So this would be supporting odd, and then this would be supporting even. And I'll go ahead and just show how you would do that for this specific question. So let's say I didn't have the multiple choice and it was just like, okay, here's the function, prove that that's, or just prove that it's even or odd. So what I would do is I'd plug in a negative x everywhere I see x. And then I would simplify. So a negative x 3 times would give you a negative x cubed, and a negative x 1 time is just negative x. I would look at the new equation that I just got and compare it to the original, and I would look. If they're exactly the same, it's even. They're not exactly the same, so it's not even. For odd, it's exactly opposite. So I look at the 2. Is it exactly opposite? Yes, it is. So that's how you can confirm it's odd. Okay, next one. Okay, this is just looking at the zeros and the factors. So let's go ahead and look at this one. So this one has 2 zeros, negative 3 and 2. So if negative 3 is a 0, the factor would be x plus 3. And if 2 was a 0, the factor would be x minus 2. Both of these are bouncing, or touching as they call it, so they should have a multiplicity of 2, or like an even multiplicity. So they definitely should both have a 2 on there. And the end behavior is up, up, which would mean it should be positive and even for the degree. So I'm looking for this, and then an even degree and positive in the front. So, yep, so this one, exactly. So 2 plus 2 would be 4, and they have the right 0. So this one should have been a simple question, number 5. Okay, number 6. Okay, the polynomial function, there it is. Which of the following describes the behavior of p as the input value decreases? So let's talk about that. Input value is x. So as x decreases, this is talking about end behavior. So the behavior as it decreases without bound, that just means like as we're heading to infinity or negative infinity. So this is kind of saying basically the limit as x approaches negative infinity, because it says decreases. And without bound just means like it's never stopping, basically, like it's going to infinity or negative infinity. So as x heads towards negative infinity, basically they're saying the output, which is f of x, where is f of x heading? So it's just a simple end behavior question. So because it's positive and odd, I know it would be up on the right and down on the left. So as x is heading towards negative infinity, which would mean the left-hand side, the graph is heading to negative infinity, which would mean it's decreasing. And C and D are just kind of to throw you off. If they're asking a limit or an end behavior question about polynomial functions, the answer would only be A or B. It's not going to be C or D, so those are just kind of throwing you off there. Okay, next one. This is just one of those questions where you just kind of have to look and think about it. So the answer is A, so that we can just look at that. A student starts to drive to school from home in a straight line and quickly realizes they forgot their backpack. The student stops the car and then drives back to their starting position. Or here, let me mark this up here. So yeah, so here's obviously the starting point. They start driving and then they realize, they forgot their backpack. They drive back to the starting position. For this context, which of the following graphs could model the velocity in miles per hour of the car as a function of time in hours? So this would be the time, and this would be the velocity. Assuming driving away from home involves positive velocity. Okay, so yeah. So driving away, and then he comes back. And then, okay, so let me look at the other answers just to see why those wouldn't be it. Okay, so B is the total negation of A, and it says driving away from home involves positive velocity, so right away you could take away B and D. And let's just see why it's not C. Let me click on C here. The response might come from modeling the car's distance from home instead of modeling the velocity. Okay, so yeah, so this one's just showing like straight distance, like, okay, they're this distance from home, now they're this distance, but this one is showing the velocity. So that's why it can go down in the negative area. Oh, whoops. Okay, 8 is just another one of those questions. So this is a phone battery over a period of time. So basically as time goes on, the percent charge is going down. It looks like it's going down the whole time. Yeah, so there's some areas where it kind of goes up and down at different, different rates, but it's definitely going down the whole time. So right away, you could eliminate A and B, because you see how it says sometimes decreasing and sometimes increasing. This is never increasing. So the questions or the parts you might have thought is like, okay, so like here, it's definitely like, it's still decreasing, but it's at definitely a lower rate. Like at the very beginning, it's decreasing quick. And then it decreases, but it just kind of like slower decreases. And then it starts going like more, and then whatever. But anyways, it's always decreasing, right? So it's not sometimes increasing, it's always decreasing. So definitely not A or B. Let's see what the difference is between C and D. As time increases, the charge of the battery is always decreasing. The charge is decreasing. Okay, so C says it's decreasing at the same rate all the time, and D says it's different rates. So that's why it would be D, because like I just explained, you know, it's changing at different rates. Okay, 9. Okay, perfect. So let's go ahead and do this one. This is just a simple rate of change question. Rate of change from -3 to 3. So -3 is right there, and 3 is right there. And we actually had a question like this on our last quiz. The rate of change from there to there would be 0. So that would be a constant rate of change, which is 0. There it is. Okay. Okay, so this is giving you a table, and it says basically, is it concave up or is it concave down? So what you would want to do is find the rate of change between 5 and 6, 6 and 7, 8 and 9, 9 and 10. And actually, so you would want to use the formula, right? Which is, hold on, let me do this real quick. The formula y2 minus y1 over x2 minus x1, right, for slope. And so you'd want to go like from 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. That's what you'd want to do. Since these are going up by the same increment, can I get this bigger? Okay. Since they're going up by the same increment, I can just go ahead and take a look and see what the rate of changes are doing, because these are all up. These are all going up by 1. So let's just see what's happening to the y's. So for this one, I'm going to do -27 minus -17, so plus 17. That would be going down by 10. I'm going to do -39 minus a -27, which is plus 27. That's going down by 12. This one's going down by 14. This one's going down by 16. And this one's going down by 18. So let's just look at A since we have it in the picture. It says the graph is concave up because the average rate of change is increasing. So the average rate of change is not increasing, it is definitely decreasing. The numbers are getting smaller. So this is a basic definition of concave up and concave down. If the rate of changes are increasing, it is concave up, period. If the rate of changes are decreasing, it is concave down, period. So the rate of changes are decreasing. So the graph is concave down, this is choice D, because the average rate of change over consecutive equal length intervals is decreasing. Oh, okay, and there's one on the last quiz we took, they don't have it here, but on the reasoning, it said it's concave up because the average rate of change is positive, or it's concave down because the average rate of change is negative. That would not be a valid answer. It is only because the average rate of changes are decreasing. They could have all been positive. Like if it was like, 10, let's say the rate of changes were 10, and then 8, and then 6, and then 4, and then 2. All of these rate of changes are positive. It still could be concave down, which it is because the rate of changes are decreasing. So as long as the rate of changes are decreasing, it is concave down. Not necessarily because they're negative, but because they are decreasing. And that's not something that's on these choices, but it was on the last quiz. Okay, this one we have an end behavior. So let's just go ahead and draw like what this little graph would look something like. Let's put most of the choices in the picture. Okay, so as x heads to negative infinity, f of x heads towards negative, so that's going to be facing down. And as it goes to positive infinity, f of x heads towards, so it's a down, down. So I'm just going to do like a little boop. There we go. Okay. So let's read question A. The value of A must be positive. Okay, right there. A is the leading coefficient. I know right away the leading coefficient cannot be positive because it's heading down on the right. Definitely not A. The value of A must be negative. That is true. Let's read the rest here. Okay, must be. Let's see. It must be negative, yeah. Because as X increases without bound, the end behaviors are different. So now this is interesting. That is not the right reasoning. So this is somewhere I guess that maybe try to trip you up here. That's what I circled there. That is a true statement. A must be negative because it's going down on the right. But it's not because the end behaviors are different. What is this describing? When the end behaviors are different, that would be describing an odd degree. So it's kind of testing to see if you know if these go together or not. So that's why they wouldn't. This one says the value of B must be even. B is the degree. They're both heading down, so yes, that is a true statement. Is that because the end behaviors are the same? Yes, that is. So you have to make sure you have the correct answer, but also the correct reasoning. So that's why I went over with the last question about concave up and concave down, because it's not showing it here, but if you have the wrong reasoning but the right answer, you'll get it wrong. So you do have to know the reasoning behind it. Okay, number 12. Okay, this is just another concave down question. So let me just show this one. Yeah, so concave down is when the rate of changes are decreasing. So here it's like positive, here it's a little less positive, constant, negative, more negative, right? So this whole section here, this is concave down. And then whenever it starts going back up, that's concave up. So, oh, wow. Darn. Maybe let's put this in a different color. So it's kind of hard to tell exactly where it's going. I would say maybe like around, yeah, I don't know, maybe around there it's going concave up. And then here, you know, it's concave down. So I would say concave down there and concave up there. Let's go ahead and look at the answer choices. So I'd like to show it. Okay, negative infinity to -2. So that would be, right, exactly, that's exactly where I kind of put it. Let's look at the other answer choices though. Negative infinity to -4 and 0 to infinity. So let's look at that. Negative infinity to -4 would be this piece, and that is concave down, but they also said from 0 to infinity, but that's concave up. So that's partially right, partially wrong, so that wouldn't be right. This one says -2 to infinity. That's obviously concave up, so that's not going to be concave down. -4 to 0. Yeah, so because like around here is where it changes from concave up to concave down, they're trying to see if you can realize that. So that's called, that little point right there is called the point of inflection. And it's where it switches from concave up to concave down. So yeah, so that's why that last one is kind of trying to trick you there. Well, not trick you, but you know, try to make sure you know. So yeah, -4 to 0 would be kind of trying to see if you know that. Let's see what they say about that one. Oh yeah, they're just saying you would assume it's concave up when it's, or concave down when the function is decreasing, but oh yeah, true, because some people might get confused between the difference between like increasing, decreasing, and concave up. So like this part here, it's increasing, so people are probably not inclined to say that that would be concave down if it's increasing, but remember, it doesn't have to do with that. It just has to do if the rate of changes are decreasing. Okay, let's go to the next. Okay, so let's just read this like by each one. For number, let's just go one by one. So let's go to A. At point A, the rate of change is negative. Look at this. Rate of change is positive, so right away, let's get away from A. It's not right. Okay, let's go to B. At point A, the rate of change is negative. We just said that wasn't right, so okay, let's just move on. Okay, C and D says the rate of change is positive, which is correct. We just have to determine if it's concave up or concave down. So at A, so this is just more of like a visual, I would say, for this one. Yeah, I mean, you can see that this area right here is concave down. So yeah, again, it's just kind of like a more of a visual thing. I would say it's concave up, like here. This is probably the point of inflection right there. So that's where it changes from concave up. Again, it's just more of like a visual. Okay, 14. Wait, is there only 15 questions? Because one of these I was gonna have you skip, but I haven't seen it. It might have been 14. Okay, let me go to 15 and I'll come back. Okay, so 15, the polynomial function is given by, okay, so we know there's, oh, let me go ahead and mark this one. Okay, so boop, boop, boop. Okay, so that means there's 3 zeros for sure. So I'm just going to do a little sketch of this. So 1, 2, 3, put a little dot. At 2, put a dot, and then -1, put a dot. The domain is from -5 to 5, okay. So that's telling me that we've got like endpoints, not like it's not going to infinity. Let's see what A says. The graph of P intersects the x-axis at 3 points, has 4 local extrema. Oh, and is this the actual equation? Yeah, it is. Okay, so if that's the actual equation, it should be cross-cross, and it should be all multiplicity of 1. Like, they should be all crossing. And it should be up and down. So let's just go ahead and draw that, and then 2, 3, 4, 5. 2, 3, 4, 5. Okay, so down, down. Okay, so it's like something like that. I'm gonna put a big endpoint and a big endpoint right there. Okay, so this is what it looks like. Okay, so intersects the axis at 3 points, that is correct. Has 4 local extrema. Okay, so let's see if that's true. So it should be 1, 2, 3, 4. That is true. No global. Remember, global means like the highest of the high. Because they wrote this, that's endpoints. And remember, endpoints can be global. They can be the absolute maximum. If it was like going to infinity, you would say none, but this one's not. So that's not true. It does have a global extrema. That is the global extrema. Let's look at another one that's incorrect. So let's look at C. The graph of P intersects the axis at 3 points. That's correct. Has no local extrema. Okay, that's not right. Local extrema is just humps. This one has 1, 2 humps, and endpoints also count. So there are 4 local extrema. That was true. So that one's not right. I can't really see D right now, but let's just look at B. B is correct. Intersects the x-axis at 3 points. That's true. 2 local extrema. So the word extrema, just so you know, is just the plural, not the plural, but the inclusive for max and min. So when they say extrema, they're talking about maximum and minimum. It has 2 local extrema. 2 local extrema that are not also global. So these 2 endpoints right here, there and there, those are absolute or global max and mins because it's the highest of the high, the lowest of the low, and they're also called local. They are both. So it says it has two local extrema that are not. That would be this hump and that hump. And they have two global, which is boom and boom. Yeah. Okay, so that makes sense for that one. And the last one just says, has two local extrema. Yeah, this one says no global, which we knew wasn't right. So, okay, let's go back to 14. I guess there wasn't any of these that you had to skip. Okay, so let's draw this one. Okay, this one I'm going to go ahead and factor. So I'm going to pull out a negative x squared. So that should be x squared plus x, oh, whoops. Oops, okay. X squared minus x minus 20. And then I'm going to go ahead and factor that. Let's think. Negative 5 plus 4. Yeah, okay. So let's do my graph. I guess I'll graph up here. So we have a 0 at 0. We have a 0 at 5. And at negative 4. And the 0 at 0 has an M2. So I'm going to bounce there. It's negative and even, which would mean down, down. So let's go ahead and cross, bounce, and cross. So it should be looking like that. So now let's read the questions. A says it has a global minimum between negative 4 and 0. So right there you can tell that is a maximum. So it's definitely not true. B has a global maximum between negative 4 and 0. Okay, that question, okay, let's go back to this one. We'll see. We'll come back to that because that kind of looks like it could be true. So let's, from negative 4 to 0, yeah, that looks, okay, that's okay. Let's keep going. H has a global minimum between x equals 0 and x equals 5. Again, can't be true there. That's definitely not true. Has a global maximum between 0 and 5. Yeah, this one's kind of weird because I'll look at the explanation for B because it looks like both of those, could be true if we don't put it in a calculator. I guess we could plug in numbers to see, but I'm trying to figure out, because we don't really know which one goes higher per se. Like this one could go higher. We don't really know unless we put it in a graphing calculator or we plotted some points. Okay, let's go ahead and look at the reasoning for not B. Okay, well, let's look at D. It says, okay, boop, 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 we did that. Okay, so it says the function has a local maxima between negative 4 and 0 and 0 and 5, which we determined. So it says the interval from 0 to 5 is of a greater length, and the function attains a greater maximum on the interval. Okay, so this is, okay, that's interesting. All right, let's go ahead and, let's, I'm gonna underline it. The function attains a greater maximum at the interval of greater length. See, I would assume it would be the opposite, so that's interesting. Okay, so yeah, so I guess if there's a larger interval, then the function would attain a greater maximum. So that's something you can notate in your notes. Okay. All right. Okay, so I think that's it for these. Okay, yes.